you get the benefits all the way down. So the meat of this talk is supposed to be about what's been going on in Kerchunk more recently. And some of these go back to almost a year. The idea for storing the outputs of the Kerchunk scanning process in Parquet is almost a year old. But a lot of work has gone into making that a pleasant experience, making it work well, optimizing it in various ways. In particular, and I'm going to give a little detail on what these mean in the next couple of slides. In particular, you can take reference sets that have been saved to Parquet, and you can combine them into aggregate Parquet datasets, where the aggregate dataset is looking over a whole, maybe thousands of input files, and you can go from Parquet storage to Parquet storage without having to have some intermediate representation. And that means that you can combine things with a much, much lower memory footprint than you could before. Xarray has gained a Kerchunk backend. So that means that you can open one of these reference sets using engine equals Kerchunk. That's very convenient. Now, you could always open these, but the size of the set of arguments that you need to pass to Xarray to get things to open has become much smaller, which is nice. Along the way, and much of this is thanks to my colleagues at Carbon Plan, who are probably here. I don't see the attendee list at the moment. We have tutorials on Pythia. We have blogs from Carbon Plan and from other people about this whole process. So we get the word out, and we are encountering some interesting data sets along the way. Alongside this, there's been improvements in the GRIB interpretation. A number of people have been involved in this, including, I mentioned Gribberish here because I hadn't heard of it until yesterday, is a Rust implementation of a GRIB reader. It's not the only one, even, it turns out. It turns out that we can make a lot of progress in uncomfortable data formats within the scope of Kerchunk. Or you don't have to have Kerchunk actually to use something like Gribberish, but these things work together very nicely. There's been additional ways of scanning, so actually including maybe Zarr datasets within your aggregate Kerchunk dataset. So you could, for example, make an image pyramid where the highest resolution stuff is the archival HDF5 or TIFF or something, but then you make the sub-sampled versions of that so that you can have a pleasant browsing, viewing experience. You can make the sub-sampled versions of that in Zarr. You can reference the whole thing in a Kerchunk dataset. And then finally, append mode, which I'll talk about in a moment. A little detail on the Parquet storage. Here is a kind of layout of how this would look. Instead of storing all of your references as a massive JSON, which is what we were doing so far, JSON has the huge advantage that you can look at it. You can understand what's going on there. But if the number of references increases, eventually it's going to get very big. Big on disk and big in memory because it's a bunch of Python objects. So in Python, even just a simple integer takes much more than the 8 bytes that you think an integer might take. I don't know what it's like, 25 or 30 bytes or something like that. That's a pretty big factor. And if you're having these in lists and in dictionaries, it adds up very quickly. So if we store it in Parquet and load them as arrays, then you get a big memory saving just because of that. Also, these things are lazy. So I see, here's an example, ref0, ref1 within the layout, by the way, here is the same layout as the Zarr store itself. So here's the root ref.parquet. We have some array called name. And within that array, we have references. The first 10,000, or this is a configurable number. The first 10,000 would be in this reference 0, and the next 10,000 in reference 1 until we run out of references. That means when you're accessing these references, you're accessing the chunks of the data, you only need to load the one of these that you actually need. And that is also a big memory saving there. In fact, if you're processing through the whole of the data set, first you'll read the references from here, and then you'll read references from here, and you'll drop those. So you get memory savings there again. Also, this improves random access times. So if you have lots of these subsets of references and you want just one of them, just a single chunk, you don't need to load them all. You just need to load the one that you're after. Okay, so that's a pretty big deal, and it took a major amount of work over the summer mostly to get this right. More recently, and I mentioned this already, the Parquet storage is an implementation that lives within fsspec for the moment. That the class that handles this is now writable. So you can change the references in place and you can save them back to their original storage. And that means that you can fill a Parquet reference set from scratch. And this is exactly what we do in this Parquet to Parquet workflow that I already mentioned, which unblocks a lot of really big scale combined workflows. And it also allows for append, which is next. And finally, I have done some documentation on this. Now, this thing here that I'm demonstrating is like that's already some of the documentation of how this works. The Z metadata is actually a JSON that looks a lot like a consolidated metadata that people might be used to. But there's room for improvement here. For example, if this deep.name array is very small, maybe it doesn't make sense to actually write a Parquet file for it. Maybe we can fold that into the original. For some cases, at the moment, you can't do that. You may end up with a lot of files. So that's one thing that we can work on. And then finally, append. So this is the case where you've done a massive aggregate. Let's say it's a time series. You've done all of the years from 1980 to just last year, and then you get another month of data. You don't want to have to redo the whole combine from scratch to make your aggregate Kerchunk reference set. So now you have the opportunity to .append, and you can do that with JSON or Parquet. And that means that some workflows will get a massive improvement to how you go about them. That's very new and poorly tested at the moment. That was the last thing that we proposed as part of the Kerchunk carbon plan workflow, work plan, or whatever it was, that has now ended. Okay, so for discussion, and I want everybody to chime in, whoever has ideas. These are some of the things that were already mentioned in the dedicated thread and in various conversations. So I'm going to come back to this list and we can talk about all of these things. I don't need to explicitly go through them. I think they're self-explanatory. So we're already 20 past, and I think it's a good time to say we're going to discuss these things. And yeah, open to the floor. First, if you have any specific questions about what I've presented or how Kerchunk works or anything like that, and then we can talk about all of these next steps.
Great, thanks. Yeah, let's open up the floor for questions, comments, thoughts. And folks could go ahead and just virtually raise their hand, just so we can start organizing feedback. Tom.
Hey, thanks, Martin. There's been a lot of suggestions by me and some activity in Zarr over the past couple of weeks that I think a lot of which can be discussed together. And so I'd like to just kind of like propose a vision for how that might work and link it to some of the things that are currently on various different issues across Kerchunk and Zarr specs. So basically, Kerchunk currently does a few different things all under the banner of Kerchunk. It reads legacy file formats to find byte ranges. It then has its own like internal dictionary representation of what's effectively a Zarr array, and then it provides functions for combining said dictionaries together, serializing them out, and reading them via fsspec. And I think that most of the different things I've just listed can be done separately, and it may be a good idea for some of them to be upstreamed into Zarr specifically. So to be explicit, I think that I would like to see something like Kerchunk opens a legacy file. It then reads the byte ranges and returns some kind of array, duck array object that I'm going to call like a virtual Zarr array or a Kerchunk array. And that contains basically a list of all the byte ranges of all the chunks that you would need to make up everything in that array. And the advantage of this is that that is a well-defined API that basically maps onto one Zarr array. And once you have that, you can treat it like a NumPy array and you can concatenate it and so on, which means that you could, for example, wrap it with Xarray and use Xarray's API to concatenate and merge. So there we already managed to split off. We managed to standardize a unclear part of Kerchunk's data model by standardizing it to Zarr's data model more explicitly. And then we also solved this problem of the Kerchunk combine module being basically a second way of doing what we can already do by concatenating array objects. Then this could already work on its own, and like that's one possible vision for like a future of Kerchunk. But if we're going to do that, we might want to consider doing some of that stuff in the form of Zarr enhancement proposals. And there's two of particular interest recently, which I've linked to in the doc. And one of them is this idea of a chunk manifest, which is basically making Zarr, basically upstreaming like Kerchunk's idea of references, but into Zarr itself, so that there's a manifest file that lists byte ranges in the Zarr store itself that point to byte ranges in like the legacy file formats like netcdf. And the advantage of doing it in Zarr is that then you could you're really putting in the effort to make it an explicit standard, and you are making it so that it can be opened by multiple different languages. And then the second one of interest is the idea of virtual concatenation also being recorded in the Zarr store. And that becomes particularly useful for concatenating data sets that have different codecs, and then again making it so that you record the arrays you needed to concatenate into the Zarr store with this set, and then again you have a language agnostic specification for reading them back out again. And there's a huge amount of crossover here with what Kerchunk currently does, but a lot of what I'm suggesting is really about like being much more clear about like what the data model is at each layer, so that the layers become like composable rather than being part of like a sort of more monolithic Kerchunk umbrella, which is how I think it currently, what the current state is. That's a lot in one go, but I'm very interested in this, and I think that it could be very powerful. And yeah, I kind of wanted to just throw all of that out at once because it's all closely related.
I want to give opportunity for as many people to speak as possible, so I won't go into all of that, but I hope that everybody is trying to digest it. A lot of this is written down, as you said, in various places. I will say that my experience with Zeps and the Zarr process has left me a little cold. It's much easier to implement features and to move fast. You could argue we have sufficient complexity in Kerchunk that it's no longer able to move fast. But to get to this point, I don't think we definitely could not have done that under the aegis of Zarr. I'd be interested if there's the one example of concatenation, but we have various modes of concatenation and or merging or whatever. And I don't know how, I don't see how the different layers fit together, but we can work on making that happen. I don't need to own this, but I do want to see it succeed. if we can leverage code that lives in X-ray to do the combinations of things and then save that to a manifest that is well specified in Zarr, that's all good. I'd be definitely behind that. But let's let some other people have some comments. That's this bit essentially. move and manifest. I just put 2 minutes on.
David, do you want to go?
Sure. I just want to say how enthusiastic I am about Zarr. For Chemo Energy, where we've been using Zarr operationally for electric load forecasting, pulling in data from NOAA, NODD, per model, and now RFS model, and GFS and GEFS models now. And it's been fantastic way to access the NOAA GRIB data and build these long time series aggregations of the 18-hour forecast and the 12-hour forecast for doing machine learning for electric load forecasting. And we had an initial version that was purely built on using multi-Zarr, multi-Zarr to Zarr combined function. And recently, over the last couple of months, we worked on a sort of second pass of that allows us to do some new things, particularly parsing and building aggregations from the IDX text files that NODD recently added, and some tools around that have been really helpful. And excited to contribute some of that back to wherever it should live and work with the community to put it in a form that's useful to other folks as much as possible. Because it's such a fantastic resource with NODD and its capability. So I'm excited to contribute on that. The next thing I want to work on is figuring out how to improve the I/O. So I'm really excited about the second option there. The second item in the list. Now that we can build these massive aggregations, 4 years of HRR data set, or 4 years of 15-minute, sub-hourly her model output. I want to improve the I/O, and looking for ideas there, where we're trying to do like a X-ray interpolation to a point to get a time series out of these, or multiple time series at a bunch of points out of these grid file aggregations, and we find it's painfully slow right now, and figure out where we could do that and how we could get some parallelism in the I/O that we don't see at the moment. So very excited about Gibberish and the Rust implementation of fsspec that Martin started playing with last year, and then seeing where in the X-ray and Zarr layers we'd need to add some parallelism to take advantage of that.
I think I might be right in saying that in the typical HDF case that we started off with in fairly large chunks, I/O throughput was not an issue, and people, you maxed out your connection for any reasonable workload. Well, Grib is special, as you know.
Yes, Grib is very special.
Matt, go ahead.
Hi, everyone. Thanks, Martin, for talking about this. I wrote Gibberish. It is very much a prototype, but thanks for shouting it out. The main thing I wanted to say was that we are starting to build web services with XPublish, which I think has been talked about here before, which is basically, system to serve up X-ray data sets over the web. And I think the biggest problem for us is similar to David's, which is async IO, because we can load we have these large virtual aggregations and they work really well. All of our bottlenecks are doing asynchronous pulling of, like, say we have 100 chunks we need to pull down to build a time series. There's no real way to do that asynchronously with X-ray. And So while there may be with Zarr v3 a way to do that with Zarr, I don't think that there is a way to do that with X-ray. And part of Kerchunk is that you have a lot of little web fetches to do, right, to pull down all your chunks. So figuring out a way to do that all async and still get the compute and API from X-ray would be really powerful for us.
It does work. We have pretty good evidence of it working quite well in the context of Dask. Dask has a number of threads and possibly workers in various different places in combination with concurrency. So each of your Dask partitions is of order 10 or something like that Zarr chunks. Of course, it depends on how big those native chunks are. Like native, I mean the original files that you're reading from. So if you have 1K chunks or something like that in your HDF5, then it's going to be really hard no matter what. You have to end up reading them all. And the fsspec backend does try to consolidate reads that are nearby within a particular file. So there is something there, but there's no getting around what the basic data is. If they're reasonable sized chunks, then it's going to work well.
Yeah, we've played with the Dask methodology, but I think the API could be clearer, I think. And sometimes you don't want the overhead of using distributed Dask. I know you can do like the within process, but there is still overhead to that versus if you're in like a JavaScript world, right? If you're just doing async IO to pull down to do web stuff, you don't have as much overhead with the concurrency. That's all. We're working on ways to like work around it, and the best way we can do it with Dask now, but just something in the future, I think we'll be looking towards.
Yeah, that's it's part of the bigger question of where should all of this logic live. It would be totally reasonable if somebody had the time and effort to implement the whole thing, fsspec and Kerchunk and Zarr, all the way down in Rust. And it could be done presumably quite performantly, 0 copies all the way down. You'd have to do quite a lot of work, all of the codecs, and but it's not insane actually, because Zarr itself is pretty simple. The fsspec API is pretty simple. I don't think in practice anybody's going to do that. So you have to then decide how much of it can you shuffle down, when is it worthwhile, when isn't it? And actually, Python async IO is generally not so bad, so long as you don't have too many tasks.
Yeah, I think Python async IO is good enough. It's just a matter of how you use that with the best way to use that with these tools, I think, is where I'm getting at, what I'm getting at.
Yeah, well, feel free to point me to the place in your code where this happens with an publish at the moment, and maybe I'll have some suggestions, because that is a different context to all the notebook examples that you see, for example. Right, there you're using X-ray in interactive mode, and everything's going through that one particular pattern.
Luis?
Yeah. So I'm kind of thinking related to both of your issues. Well, not issues, but UX, I guess. Like things where this could be more streamlined. Stack has this stack API kind of thing for serving stack catalogs on the fly, right? So I wonder if, Martin, have you thought about some analogous mechanism for Kerchunk, where you can have a backend that will serve those, do the assembling, for example, call it Kerchunk API. And the heavy lifting wouldn't be on the client because you'll assemble the virtual data set where the data lives. Of course, this is a different approach to all have it in client. But have you thought about that?
Yeah, Kerchunk has tried to be simple in that sense, not to have a service as anything, but as you just heard, you can use it in combination with something like Xpublish to give that service, of course, but to build it on the fly and make combinations on the fly, we found so far that each of the combined tasks, and this is true also if you're doing OpenMF dataset and X-ray, often you need extra information. Often you really care about the order that things come in. You have to say how you need to combine each particular dataset. They all have their quirks. You need pre-processing and various different things. So to automate over a large variety of possible data sets is difficult. What I think the best route might be what Pangeo Forge has been trying to do, which is we're going to make recipes for each of the interesting data sets. We're going to figure out how to combine it, and we're going to run it and have that artifact for people to use. And then it becomes a question of effort. Who's going to, it's best if you crowdsource, you have lots of people trying to make these recipes, and you can catalog them. Say, here are the things that we know work well with Kerchunk, and you only need to look in this one place. Those pieces are missing. Kerchunk on the client, once you have the references, Kerchunk on the client is light. It's the creating the references that's the difficult part.
Any other questions? Feedback? If not, thanks so much, Martin, for presenting. And I know at least a good portion of the talk was recorded. We ran into some recording issues at the beginning, so didn't catch this till all the beginning part. But a bulk of it was recorded.
You missed the hearts?
Yes. Apologize there. Yeah, Rich wasn't able to make it, so I'm filling in, and yeah, ran into some permissions issues there. But no worries. So yeah, again, thanks Martin for presenting. Really good discussion. Try to jot down some of that discussion within the notes. If you have any other thoughts or revisions to some of the notes that we took, please go through and update that accordingly. So